Hi, hello students. Good evening all of you. I hope I am perfectly audible and visible to each and everyone present over here to watch this particular session. Okay, today this particular session we are going to discuss our chapter Chemical Bonding and Molecular Structure, the second part. In this session we are mainly focusing on the topic that is the bond parameters and ionic bond. Let us start the session quickly. Okay. What do you mean by an ionic bond? Hi Anish, good evening. The ionic bond is defined as the chemical bond which is formed by the transfer of electrons between the atoms, right? The transfer of electrons. As you can see here, I have already highlighted here. This is the bond formed by the transfer of electrons from one atom, mainly from metal to non-metal. The main aim is to form the chemical bond is that I have already mentioned in our previous session that to attain the octet, right? Otherwise, we have to get the noble gas electronic configuration, right? That type of bond is known as the ionic bond, or otherwise it is also known as electrovalent bond. Clear? Now we have to discuss about what are the factors which affect the ionic bond. As you can see over here, these are the main factors which is affecting the formation of an ionic bond. In the previous classes about the periodic table chapter, I have already discussed about these factors, right? Ionization enthalpy, electron affinity, and today we are going to discuss about the new term that is lattice enthalpy. Okay, let us start. In order to form the ionic bond or an ionic compound, we have the metal atom having low ionization energy. Okay, I hope you have the idea about what is the low ionization energy. Ionization energy or enthalpy is known as the amount of energy required to release electrons, right? So if you are taking any metal which have the low ionization enthalpy, it will form the strong electrovalent compound or ionic compound, right? Now, what about the second factor, that is the electron affinity? As I already mentioned that in the formation of an ionic bond or an ionic compound, a metal should be there as well as a non-metal should be there. Metal will lose electrons to the non-metal and non-metal will accept the electron, right? So, in order to form the strong electrovalent bond or the ionic bond, a non-metal must have the high electron affinity, right? This will be the second parameter which affects the ionic bond formation or ionic compound formation. Clear? Now, the third parameter which affect the formation of ionic bond or ionic compound is known as the lattice enthalpy. What do you mean by a lattice enthalpy? Lattice enthalpy is defined as it is the particular character of an ionic solid, right, or ionic compound, which is defined as the energy required to form completely separate 1 mole of a substance, separate 1 mole of a solid substance into their gaseous constituent. Right? If you am taking an NaCl molecule, in order to break the NaCl molecule into Na plus and Cl minus ion, that amount of energy required is known as the lattice energy. Clear? So, we can say that more the lattice energy, more stable will be the ionic compound form. Clear? Yes, fine. Now, let us move to the main agenda of this class, that is the bond parameters. What do you mean by bond parameters, or what are the different types of bond parameters which describe the bond, right? Parameters, which means that something that define the bond, right? So we can see here, these are the 4 parameters which we are going to discuss in detail in our class. First one, it is bond order. The second one, bond length. Third one, it is bond angle, and the last one, it is bond enthalpy, right? Let us start with one by one. The first one is the bond length. What do you mean by bond length? length defines as the distance, right? Distance or any measurement, right? So we can say that bond length is defined as the equilibrium distance between the nuclei of two covalently bonded atoms, right? Nuclei of two covalently bonded atoms. As we have already mentioned that about the covalent bond. What do you mean by a covalent bond? By sharing of electrons, right? Yes, by sharing of electrons, we can form a covalent bond. If you are considering a covalently bonded atoms or compound, we can say that the equilibrium distance between the two atoms, which is formed in a covalent bond, is known as the bond length or bond distance. Clear? Now, the bond lengths are measured in spectroscopy or X-ray or electron diffraction method. As you already know that the atom is very small, right? We cannot measure the distance by using any scale or any other parameters. Only the spectroscopy method or the electron or X-ray diffraction method are used for measuring this bond length. Which means that its unit is very small. It's about angstrom or picometer, 10 raised to minus 10 meter or 10 raised to minus 12 meter. Very small amount, right? So, in pictorially, we can represent the bond length as here. These are the two atoms, right? These are the two atoms I am taking here. The small one will be the cation and bigger one will be the anion. So, this will be the nucleus. As you can see here, the distance between the two nuclei of the two atoms, A and B, right? This will be our bond length. Or we can say that from here to here, right? From one distance to their nuclei, it is known as the covalent radii, right? Ra is known as the covalent radii of first atom, that is A. Then what about the second one, Rb? It is the half of the distance between the nuclei of atom towards the center, right? Rb is known as the covalent radii of B. So we can say that the complete bond length of the two atoms will be the sum of covalent radii of each atoms. As you can see here, bond length of AB is equal to Ra plus Rb, where Ra is the covalent radii of A and Rb is the covalent radii of B respectively. Clear? Now here you can see a table about the average bond length of the sum of the molecules. For OH molecule it is 96 picometer or angstrom. Again CH it is 107, NO it is 136 and so on, right? As you can see here, while moving from single bond to double bond, right? Single bond to double bond, what happens here? What will happen to the magnitude of bond length? Whether it is decreasing or increasing? CC single bond it is 154, right? While moving from C double bond C it is 133. Then for C triple bond C it is 120, which means that the bond length decreases as the number of bonds increases, right? As the number of bonds increases, bond length decreases. So we can say that the bond length is inversely proportional to the bond order or the number of bonds present in a molecule, right? Bond order or number of bonds present in a molecule. This is one of the important relation you have to be noted. Clear? Now let us see what are the parameters. You don't need to memorize the table completely. You must have an idea about what will happen to the bond length as the bond order increases or the electronegativity or the size of the atoms increases only. I will see the next slide also. I will show you what will happen to the bond length and bond order. Okay, these are the important features you have to be noted. No need to memorize the complete table, right? Anish. Okay, the first parameter is that the magnitude of the bond length between the same atoms. But the magnitude of bond length between the same atoms in different molecules will be same, right? If I am taking an OH molecule, or OH bond length is same in the case of water molecule as well as hydrogen peroxide as well as C2H5OH. If we are considering different molecules also, if they contain the same atoms like OH, their bond length will be same. Clear? Which is found to be 96 picometer. Now, the second point is that if the bond type is different, in the case of different molecule, if the bond type is different, again that will happen, that bond length also changes. Just opposed to this, right? Now, what will happen to the size of the atoms? If the size of the atom increases, what will happen to the bond length? For example, if I am taking the example here, our halogen group, right? Starting from fluorine, chlorine, bromine and iodine, which means that as the size of the bonded atom increases, bond length also increases, which means that there will be directly proportional relationship, right? These are the size order, right? Whenever we are moving from top to bottom in a group. For example, if I am taking the halogen group from fluorine to chlorine, chlorine to bromine, bromine to iodine, which means that size increases, right? As the size increases, the bond length also increases. HF bond length is less as compared to HCl, HBr and HI. Clear? Aditya, you will study in detail about the free radical, about their homolytic cleavage, right? In the case of organic chemistry. Simply, I will give a brief idea that if you are taking any of the atoms, if for example, if I am taking A, B compound, right? If the cleavage is happening here, for example, if the bond is broken here, equally the electrons are changing here, right? If the equal electrons are changing here or the cleavage is happening equally, we can say that it will form two radicals, right? One is A dot, then the other one is B dot. This type of cleavage is known as the homolytic cleavage, and the radical which is formed as a result of homolytic cleavage is known as the free radical. Clear? You can say that A dot is the one free radical and B dot is the another free radical. I hope it is clear for you. Now let us see what is the next parameter. Okay. Now, if we are considering the homonuclear molecule, right? Homonuclear diatomic molecule means the atoms which contain same number of molecules. See, the atoms which are containing the same number of atoms. For example, if I am taking the H2 molecule, right? Which is formed by the two hydrogen atoms, right? So their bond length will be the twice of covalent radius. We already mentioned that bond length will be the twice of covalent radius, right? If I am taking AB atom, the covalent radii of A plus covalent radii of B is equal to bond length. So, if I am taking a homodiatomic molecule like hydrogen molecule, then what will be the bond length? The same side, right? We are just adding, which means covalent radii of one hydrogen plus covalent radii of another hydrogen, which means twice of covalent radii of hydrogen, right? That will be the relation. For example, if the hydrogen atom having the covalent radius of 37 picometer, then what will be the bond length of hydrogen molecule H2? Double, right? 37 into 2, that is equal to 74 picometer. Now, we already mentioned that about the bond order discussed, right? If the number of bonds present on a molecule increases, bond length, what will happen bond length? Bond length decreases, right? So, we can say that single bond C have the maximum bond length as compared to double bond and triple bond. Clear? Hi Aryang. Okay, these are the important parameters which is related to the bond length. I hope it is clear for everyone. Now let me move to the next parameter, that is bond energy. So that if I am taking any one of the bond here, HF, HH or anything, I want to break this. What I will do? We have to give some energy, right? We have to give some energy to break the bond. That type of energy is known as the bond energy, which is our second parameter, which is also known as the bond enthalpy. So we can define the bond enthalpy or bond energy as the amount of energy required to break 1 mole of a diatomic molecule or a polyatomic molecule. We can say that simply the molecule in the gaseous state into their free constituent ions or atoms, right? This is known as the bond enthalpy. For example, if I am taking any of the molecule, if I am taking this one, HH, right? I want to break these hydrogen bond into simple hydrogen, right? So what I will do? I will give some energy to that. That type of energy is known as the bond energy or bond enthalpy, right? So we can say that the unit of bond enthalpy is always given as kilojoule per mole or kilojoule mole inverse, right? Here you can see these are the examples. If I am breaking the HH bond here, this is mentioned that its molecule should be in the gaseous state. Molecule should be in the gaseous state. So you can say that 2 hydrogen will form by releasing the energy of, by giving the energy of 436 kilojoule per mole inverse. This energy will be the bond energy of this particular molecule, right? And also bond length is also mentioned here. It is 74 picometer. Then what about this chlorine molecule? Cl molecule, right? So I am giving an amount of 242 kilojoule per mole energy to this particular bond, then it will break, right? This will be the specific bond enthalpy or bond energy of chlorine molecule. Clear? Okay, what is the definition of bond enthalpy, Anish? It is the energy required to break 1 mole of substance, right? 1 mole of substance, right? So if I am taking a 1 mole of substance to break the energy, general energy unit is kilojoule or joule, right? If I am taking 1 mole substance, it will be, the unit will become kilojoule per mole, right? Clear? Joule or kilojoule is the general unit of energy. If here we are considering the 1 mole of substance, so it will become kilojoule per mole or kilojoule mole inverse. Clear? Now, yes. Now I can say that the bond dissociation energy, right? We can call the bond enthalpy or bond energy, otherwise known as bond dissociation energy, because energy is used to dissociate, right? So we can say that it is always positive. How it will become positive? How it will become positive? Is there any chance to become negative? Okay, we have already discussed that in the case of bond dissociation energy or bond enthalpy, energy is always given to the molecule, right, to break the bond. So we can say that energy is absorbing. So we can say that it is always positive, right? It is always positive. Now I have a question for you. If I am giving 20 kilojoule per mole of energy to break a bond, for example, if I am taking an AB bond, if I am giving 20 kilojoule per mole inverse or per mole energy is given to break the AB molecule, what will be the energy used to form that AB molecule? Any idea? Or you can give me the answer by reading the slide also. It is already written here. Fine. It is mentioned that the amount of energy released on forming a bond is always the bond dissociation enthalpy with a negative value. For example, if I am taking the example of, if I am taking AB molecule, right? If I want to break the bond AB into A and B, I will give it as 20 kilojoule per mole, right? So, the amount of energy required to form this AB bond is the negative of the same magnitude, right? Negative of the same magnitude. So, I can say that this energy will be minus 20 kilojoule per mole. Clear? Here you can see that some of the elements with their bond energy. Again, CC single bond having 341. While moving from single bond to double bond to triple bond, what will happen to the bond energy? Whether it is increasing or decreasing. Increases, right? First one it is 341, then it is 610, then it is 827, which means that as the number of bonds increases, bond energy also increases, right? Which means that bond energy is directly proportional to the bond order. Okay. Now, I have already mentioned that in the case of a diatomic molecule or the single molecule, we can say that this is simple energy, right? We are used to break the molecule. But if I am considering any other polyatomic molecule, right? For example, if I am taking water molecule, if I am taking water molecule, this will be our water molecule, right? H2O. What will be the energy required to break this molecule? 2 OH bonds are there, right? So we assume that this energy will be same. But in actual practice, it is say that in order to break this one bond, it will be one energy. In order to break the another bond, OH bond, it will be another energy. Which means that the total energy will be the average of these two bond energies, right? So we can say that in a polyatomic molecule, the bond enthalpy is different from bond dissociation enthalpy. Why? Because the bond energy is the average of various bond dissociation energies of the similar bonds of it. For example, in the case of water molecule, it will be the average of 2 OH bond dissociation, right? So, the detailed reaction is given here. In the case of first water molecule, it will break into H plus OH, right? Where the first energy is 502 kilojoule per mole. Then again it will break into, this OH bond is break into H plus oxygen by giving the energy of 427 kilojoule per mole. So in total we can say that the complete bond enthalpy or complete bond energy of this particular water molecule is the average of these two, right? 502 plus 427 whole divided by 2, that is equal to 464.5 kilojoule per mole. Clear? Now let us see what are the parameters. Again, what are the effects or the parameters or the aspects about the bond energy or bond enthalpy. The first one, we already mentioned that as the number of bonds increases, the overall bond strength or bond enthalpy also increases, right? As you can see here, this is a single bond, right? CC single bond. Energy is about 341.41 kilojoule per mole. Then what about the double bond? 610.7 kilojoule per mole, increases, right? Again, what about the triple bond C? It is 827.6 kilojoule per mole. As the number of bonds present in the molecule increases, bond energy or the bond strength also increases. I hope the point was clear for everyone. Now, what is the next parameter? This is the next one. If the bonded atom contain any of the lone pair, at least one or two lone pair, what will happen to the bond energy? I will show the example first, then you will identify. Okay, this is the first bond, right? C is single bond, there will be no lone pairs. Then what about nitrogen? 2, which means two lone pairs are present, right, in the case of nitrogen. In the case of oxygen, it is in total 1, 2, 3, 4, right? 4 lone pairs are present. As you can see here, while moving from carbon to nitrogen to oxygen, number of lone pairs increases, right? Number of lone pairs increases. I will represent it as LP. Number of lone pairs increases. So that what will happen to the energy? From first it is 341, then it is 162, then it is 146, which means that bond energy or bond strength decreases. Clear? As the number of lone pairs increases, the bond energy decreases. Now, next parameter is the size of the bonded atoms, right? The bond energies of similar type of bonds gradually decreases down the group. Similarly, if you am taking the example of halogen atom or from fluorine to chlorine to bromine to iodine, what will happen to the size? Down the group. While moving from fluorine to chlorine to bromine to iodine, down the group size increases, so that the bond energy decreases, right? Which means that size of the bonded atom is inversely proportional to the bond energy. Clear? Now, let me move to the third parameter, that is the bond order. We have already discussed about the bond order, right? Bond order is simply known as the, in the case of a Lewis dot structure, we can say that the bond order is the number of bonds formed between two atoms. The number of bonds formed between two atoms. For example, if I am taking these are the three typical examples of bond order. First one is the C, single bond C. What will be the bond order there? Bond order means it is the number of bonds formed between the two atoms. What will be the bond order here in the case of C2 molecule or carbon-carbon single bond? One, right? Here only one bond is forming, so it is 1. Then what about nitrogen? Nitrogen is forming 3 bonds between these two atoms, so bond order will be 3. Similarly here, oxygen is forming 2 bonds, so bond order will be 2. So generally we can say that the total number of bonds formed between two atoms is known as the bond order. Right? Then in the examination point of view or the JEE Main or JEE Advanced, one of the important point you have to be noted that to find out the bond order of a particular species known as the isoelectronic species. What do you mean by isoelectronic species or isoelectronic molecules? Iso means same, right? Electronic means electrons, which means that two molecules or two species having the same number of electrons are known as the isoelectronic molecules or isoelectronic species. So we can say that whenever we are giving any type of molecules, you just calculate the number of electrons. So identify there whether it is isoelectronic or not, right? So we can say that the isoelectronic species always have the same bond order, right? Same bond order. For example, I am giving here, this is the F2 molecule and O2 2- molecule. Then, in order to find out the bond order of this particular molecule is very difficult, right? Till now, I hope you have no idea about the molecular orbital theory. Whenever you are studying about the molecular orbital theory, you will be aware about the molecular orbital configuration, right? Molecular orbital configuration of the particular atom. Then you will get the bond order from a particular formula. Before that, you must have an idea that this O2 minus is isoelectronic with the F2 molecule, right? If I am taking F2 molecule, how many electrons are present over here? In the case of F2 molecule, how many electrons are present in one fluorine molecule? I mean one fluorine atom or element? 9, right? Its atomic number is 9, which means it contains 9 protons and 9 electrons. So I am taking that 9 plus 9, that is equal to 18 electrons. Then we will just calculate the number of electrons in the O2 minus also. It will form O2 minus, right? In the case of one oxygen atom, it is 8 electrons. For 2 oxygen atom, it is 2 into 8, 16, right? 16 by losing 2 electrons, by adding 2 electrons, right? So I am taking plus 2 here, which means that these two species contain same number of electrons. So this is isoelectronic, right? We have already known that the bond order of F2 molecule is single bond, right? F single bond, F will be the structure of F2 molecule. So we can say that its bond order is 1. So because of the isoelectronic species, O2 minus also have the same bond order, right? Clear? Then what about these species? Just calculate whether it is getting the same number of electrons or not. In the case of N2 molecule, it is 7 plus 7, 14 electron, right? In the case of N2 molecule, it is 14 electron. What about carbon monoxide, CO? Six plus 8, right? 14. And in the case of nitrogen, NO plus, it is 7 plus 8 minus 1. Again 14 electrons, which means that these three species are isoelectronic in nature. So in the case of N2 molecule, N2 will form always bond order of 3, right? So we can say that CO as well as NO plus have the same bond order of 3. Clear? Now we are moving to the last parameter, that is the bond angle. What do you mean by the bond angle? It is something related to angle, right? It is related to the angle. Simply we can say that it is the average angle between two adjacent atoms. But in practical, when we are moving about the molecular structure or the depth in the chemical bonding, we can say that it will be the angle between orbitals containing the bonding electron pairs. It will be the angle between the orbitals that containing the bonding electron pairs are known as the bond angle, right? So if I am taking H2 molecule here, while seeing here you can identify that it will be the average angle between two atoms. But in actual practice, it will be the angle between the orbitals, right? Clear? Again, this bond angle is also calculated or measured by using the X-ray diffraction or spectroscopy techniques, and the bond angle is always expressed in degree. The unit will be degree, right? Now, in the case of JEE Main or JEE Advanced, you will get the questions about the correct order of bond angle, right? So these are the parameters or the factors that affect in the bond angle. So we already have an idea about the shape and geometry, right? Shape and geometry. Otherwise, we will study in the VSEPR theory in the next class. So the bond angle is always depends on the geometry of the molecule. Either compound having the linear geometry, right? For example, if I am taking this is the linear one, right, which is in the straight line. So we can take that the angle between these two atoms or three atoms, theta is equal to 180 degree because it is in a straight line. So depending upon the geometry of the molecule, bond angle also changes. Now, if we are discussing about the hybridization or the S character of the molecule or the hybrid orbital, we can say that as the S character in the hybrid orbital increases, the bond angle also increases. For example, if I am taking three different types of hybridization, right? sp, sp2 and sp3. What about the S character here? Here it is 50%, here it is 33.3%, then here it is 25%, right? S character. As the S character increases, bond angle also increases. So we can say that sp greater than sp2 greater than sp3. Clear? Now the next one is the effect of lone pair of electrons. The bond angle is also affected by the lone pair of electrons present in the central atom. That's the case in the case of ammonia molecule, NH3 molecule. Generally, its bond angle will be a tetrahedral angle, but due to the lone pair repulsion, you will be discussing in the VBT and VSEPR theory in detail. Its bond angle is affected by or decreased to 107 degree due to this lone pair. Clear? Now, this will be the most important parameter or the factor you have to be noted, that the electronegativity of the atoms, how it will affect the bond angle. We already know that whenever a molecule is forming, there will be a central atom as well as the surrounding atoms, right? So, as the electronegativity of the central atom increases, bond angle increases, right? This term is very important. If the electronegativity of central atom increases, bond angle increases. Then what about the surrounding atoms? If the electronegativity of surrounding atoms increases, bond angle is decreasing, inversely proportional relationship, right? Okay. In the case of ammonia molecule, there will be, in the case of ammonia molecule, there will be a lone pair, right? This is our ammonia molecule, that is NH3. This is our lone pair. In the case of VSEPR theory, you will be discussing about the lone pair repulsion. There will be a maximum of lone pair repulsion. So that in general, NH3 bond angle is tetrahedral angle, 109 something. So due to the presence of this lone pair in the nitrogen atom, this bond angle is decreases to 107 degree. Clear? Hi Harshid. Okay, then the fourth and fifth parameter is that, if I am taking this example, right, this is the OF2 molecule. These are the two molecules, OF2 and OCl2. Which one is more electronegative? Fluorine or chlorine? Yes, fluorine is more electronegativity, right? Fluorine is more electronegative. As you can see here in the case of OF2 molecule, oxygen is the central atom, right? Fluorine and chlorine are the surrounding atoms. As according to our fifth point, it is saying that the electronegativity of the surrounding atom is inversely proportional to the bond angle. So, fluorine is the most electronegative atom, right? So, it will have the less bond angle. Clear? Okay, so far we discussed about the four bond parameters, that is bond order, bond enthalpy, bond angle and bond length. So from this idea you will get an answer that what will happen to the bond order or bond enthalpy as the bond order increases? It is directly proportional, right? As the bond order increases, bond enthalpy also increases. Then it is inversely proportional to the bond angle as well as inversely proportional to the bond length, right? Clear? As the bond order increases, which means as the number of bonds increases, bond strength or bond enthalpy increases. While whenever we are moving from single bond to double bond to triple bond, bond angle as well as bond length decreases, right? This will be the final, this will be the final output of the complete bond parameters. Clear? Here is some practice questions for you. The first question is, the OH bond length in water molecule is X angstrom. Value is not given here. You will given just a symbol only. The OH bond length in H2O2 is, whether it is similar to X angstrom or greater than or less than. What will be the answer? To find out the OH bond length in H2O2 molecule, it is given that OH bond length in H2O molecule is X angstrom. What will be the answer? Option 2, right? Because this is the same bond length we are asking. In the case of, if we are considering different molecules also, if the same bond length is asking, it will be same, right? So here in the case of OH bond length is X angstrom in the case of H2 also. Similarly in the case of peroxide also, it will be same, that is X angstrom. Now here is the next question. The bond dissociation energy of the molecules A2, B2, C2 are given here in the case of magnitudes. Find out the correct decreasing order of their bond order. Bond energy is given here. You have to correlate it with the bond order. Okay. As the bond order increases, bond energy also increases, right? So we can say that there is a directly proportional relationship. As you can see here, least one is having B2, right? This will be the energy order, B2, then A2, then C2, right? B2, A2, C2. We have to find out the decreasing order. So here it is C2 greater than A2 greater than B2. Just the reverse order, right? Bond energy will be directly proportional to the bond order. So we can say that B2, A2, C2. This will be the increasing order. So here option 3 will be the correct answer. C2 is greater than, A2 is greater than B2. Clear? Now, the correct order of increasing bond angles. The compounds given are PF3, PCl3, PBr3 and PI3. And it is mentioned that here all the central atoms are same. You have to consider about the electronegativity of surrounding atoms. Then what will be the answer? Option A, right? As the electronegativity of the surrounding atom increases, bond angle decreases. So, as you can see here, in the case of fluorine to chlorine to bromine to iodine, electronegativity decreases, which means bond angle increases. Option 1 will be the correct answer. What will be the answer here? The correct order of increasing CO bond length of CO, CO3 2 minus and CO2. Just think about these molecules, then just give me the answer in the next class. I have already given that the answer is option 4. Just give me the explanation in the next class. What about that? Okay, we have one more topic to cover, that is the bond polarity. What do you mean by the bond polarity? Okay. According to the polarity, we have divided the covalent bond into two types, right? Polar covalent bond as well as non-polar covalent bond. So I can say that if I am taking the example of HCl molecule, right? In the case of HCl molecule, it is clearly visible that hydrogen and chlorine have a high electronegativity difference, right? Which means that chlorine is having the more electronegativity as compared to hydrogen. So which is saying that the chlorine is attracting its electron pairs towards its having a negative charge, delta negative charge. Clear? Then for hydrogen it will acquires a delta positive charge, which means that in the case of covalent compound also it will experience some ionic character, right? So we can say that no, any complete molecule is not completely ionic as well as ionic compound, right? There is no 100% covalent character or 100% ionic character. So, in the case of covalent molecule, it will experience some negative or positive character as compared to the ionic compound. So, the ionic nature or the character of covalent molecule is expressed by another term known as a dipole moment or polarity, right? So, I can say that this type of molecule is there is an electronegativity difference, right? So, I can call it as a polar or non-polar. Polar, right? Polar molecule. Then just opposite to that, if I am taking H2, O2, Cl2, N2 or F2 molecule, there is no any electronegativity difference, right? Both are the same atoms. So we can say that this is a pure non-polar covalent bond. There will be no domination, right? The covalent bond is formed between two similar atoms. There will be equal attraction of the electrons between the two atoms. So this is known as a non-polar covalent bond. Clear? Now, in order to measure the polar nature or the polarity of the compound or molecule, we are expressing the next term known as the dipole moment, or we can say that it is a term which is used to express the ionic character of covalent bond. So, if we are taking two different samples or two different atoms or molecules having the different charges, we can measure the dipole moment as mu is equal to delta into d, where delta is the charge on the any one of the poles. Then d will be the distance between that two poles. This is known as the dipole moment calculation. Mu is equal to delta into d, and dipole moment is usually expressed in debye units. The SI unit, the unit of dipole moment is always debye units. Otherwise, we can also We can also known as the debye is equal to coulomb meter. And there is an interconversion that, this is very important, 1 debye is equal to 3.33564 into 10 to the power minus 30 coulomb meter. Clear? We have discussed about the polarity of the bond, and we have seen that two types of covalent bonds are forming there, polar covalent bond as well as non-polar covalent bond. In order to find out the polarity of the covalent bond, we will be using the term that is known as the dipole moment, and dipole moment is mathematically expressed as mu is equal to delta into D. In the NCERT textbook, it is also mentioned that delta, otherwise it is Q, small letter q or capital Q, which is represented as the charge of the molecule, charge of the pole, right? Clear? Now, in the case of dipole moment, it is a vector quantity, right? I think you have already studied in your physics classes about the vector quantity, right? Vector and scalar quantity. In the case of vector quantity, there will be magnitude as well as direction, right? So, in the case of dipole moment, if I am taking any of the molecules here, we can represent this vector quantity as a headed arrow, right? Small arrow with tail on the positive center and head pointing towards the negative center, right? For example, this will be the X atom. Simply we are taking it as a halogen, right? Either fluorine, chlorine or iodine and so on. It will have the maximum electronegativity, which means that it will attract the electron pairs towards it. So we can say that the arrowhead will point towards the X atom and this tail will come in towards the hydrogen atom, right? This will be the representation of dipole moment of any molecule. Now, based on this dipole moment, you will get the questions like this. For example, in the case of BeF2 molecule, right? This will be the structure of the BeF2 molecule. As you can see here, in the case of BeF2 molecule, it is a linear structure, right? So here, fluorine is more electronegative. It will attract the maximum number of electron pairs towards it. So we can express that this headed arrow will turn towards this and this is in the opposite side. Which means that these arrows or the dipole moment have equal and opposite magnitude, so it will cancel each other, right? Clear? The final dipole moment of this particular molecule will become 0. Clear? Now, in the NCERT textbook, it is clearly mentioned that in the case of NH3 molecule as well as NF3 molecule, what will be the final dipole moment of the molecule? As it is seen here, it is the same molecule, right? Same shape of molecules. NH3 and NF3 are pyramidal in shape, having one lone pair of electrons on the nitrogen atom, right? One lone pair of electrons on the nitrogen atom. As we can see here, in the case of NH3 molecule, nitrogen and hydrogen, nitrogen is more electronegative, right? So, arrow will go like this. Then, in the case of lone pair electron, there will be the more energy or the attractive force, right? So, this arrow will go like this, which means that both the arrows in the same direction. So, which means that dipole moment will be maximum. Dipole moment mu will be maximum, right? Clear? Because the direction is always towards the same side, then it will become maximum. Then what about here? In the case of NF3 molecule, fluorine is more electronegative as compared to nitrogen atom, right? So, in the case of here, the arrow will come towards here, which means that the resultant arrow will be in the opposite direction, right? This will be the direction of these resultant F molecules, which means that it is equal and opposite, but we cannot cancel each other. Why? Because in the case of previous session, we have seen that in the case of here, right? BeF2 molecule, these are same molecules, right? BeF. So, we can cancel each other because of the same magnitude and same direction. But here it is lone pair, right? Lone pair have more attraction towards it. So, which seen that here this will be maximum, this will be minimum. So, we can say that we cannot say that it will be 0, but it will have a least value, which is about 0.80 into 10 to the power minus 30 coulomb meter. Clear? Okay, these are all about the dipole moment part. Now, then in the next class we will discuss about the, as I already mentioned that in the case of ionic bond, right? Ionic or covalent bond, there will be percentage character of ionic in the case of covalent bond. Similarly, in the case of ionic bond also, there will be some character of covalent character. The ionic bond of covalent character is expressed by dipole moment. Similarly, what will happen to the covalent character of ionic bond is expressed by other rule known as the Fajan's rule, right? So, we will be discussing the Fajan's rule in the next classes. Then, what will be the application of dipole moment, right? In the case of dipole moment, we can express that the percentage of ionic character in a covalent bond, right, which is given by the formula observed dipole moment divided by dipole moment of complete ionic character into 100. This will be the formula. This is very important, right? The next one, in order to find out the order of dipole moment, we have to find out whether the molecule is ortho, meta, para, right? This will be the order. In the case of benzene molecule or organic molecules, whether the molecule is having ortho, meta, para substitution, it will follow this order, right? Dipole moment is useful to ascertain the orientation of substituents in the general. Dipole moment of di-substituted benzene is here. Ortho having maximum, then meta, then para. Here it is 2.5 for debye, then it is 0, right? Clear? Again, this is the first question about the dipole moment. Which of the molecule having the molecule with a 0 dipole moment? First point, you have to be noted that whether the molecule is symmetrical, which is the symmetrical structure, then it will have the, definitely it will have the dipole moment of 0. So, if I am taking here in the case of BCl3, chlorine is having maximum electronegativity, the resultant will be here, which is equal and opposite, right? Which is equal and opposite. So, we can cancel each other. Similarly, in the case of BeCl2, it is linear. Dipole moment is equal to 0. In the case of CCl4 also, all are the similar atoms, right? So, it will experience the electronegativity difference equal and opposite in magnitude. So, we can say that all the above molecules having the dipole moment is equal to 0. Therefore, option 4 will be the correct answer. Again, take it as a homework. Based on the dipole moment, you have to identify which of the following molecule shows dipole moment among the following, which means that only one shows the non-zero dipole moment here. Take a note on it and give me the answer in the next session. Again, about the gentle reminder about the All India test series. It's again All India test series for the JEE Main session 2 and JEE Advanced 2025. You will get a discount of 2,999 by using this coupon code of U250 off. So, don't miss it. Please enroll fast. Okay, now that's all about from my side for today. I hope it was understood for everyone. And tomorrow in the next session, we will be discussing about the VSCPR theory, very important theory about the chemical bonding. Then, till then, thank you so much all of you. Don't forget to subscribe our channel. Do like, share this particular session to your friends also. Till then, bye-bye. Thank you all of you.